Today, by using the ratio of areas of two triangles, applying the property of ratio of areas of two triangles, we are going to solve some interesting problems by using the property about the ratio of areas of two triangles. First problem, we can take the problem and we can see what is given in the problem. Name of the triangle ABC given. On the side BC, D is between B and C. B dash, D dash, C is there. And what is that BD and DC relation is given there. 2 times of BD is equal to 3 times of DC, that is given there. Next, A dash, M dash, D is there. So, M is on the segment AD. And what is the relation between AM and MD? It is given there. 4 times of MD is equal to the length of AM. That is given in the problem. Find out the ratio of areas of two triangles. You can read the problem. We have to calculate the ratio of areas BMD, triangle BMD, divided by area of triangle ABC. This is our problem. We have to think about the ratio of areas of two triangles. But BMD and ABC, two different triangles are there. And if you observe them, if you consider BMD, this is BD, you can think, and if you think ABC, this is BC. So if you consider base of the second triangle BC and base of the first triangle BD, you are not getting height. Heights are different. You can see that M is the vertex of this triangle, A is the vertex of the triangle ABC. So there is no relation between base and corresponding height. Base and corresponding heights are different. But very interesting, very important problem also. You can observe carefully. If you see that triangle ABC, consider triangle ABC and next triangle ABD. If you consider two triangles, you are getting common vertex is A, and triangle ABD and triangle ABC, they are having different bases, but it will be the height same height, equal height. So let us try to use this pair. What about the pair ABD? That is your first triangle. And what is the second triangle? ABC. Try to use this pair. And for that, before that, twice BD and 3 DC is given. Let us see that what is the use of that given. You can see that this is given. Twice BD is equal to thrice DC. This is given. And if we use that, we know that BD upon DC is equal to 3 upon 2. You are getting BD upon DC. BD to DC. BD to DC. You are getting that ratio there. BD to DC. But if we do that, DC upon BD. DC upon BD. That is, you can see that it is invertendo. By invertendo, DC upon BD, it will be 2 upon 3. But if we use that, DC plus BD upon BD is equal to 2 plus 3 upon 3. So what is that DC plus BD? DC plus BD is BC. Remember that. DC plus BD is BC. DC plus BD is BC. DC plus BD is BC upon BD is equal to 5 upon 3. So this is by componendo. And we find the ratio BC upon BD. BC upon BD. We are getting that ratio BC upon BD. So you can use that invertendo also. What is that? BD. What is proved here? BD upon BC is equal to 3 upon 5. It is proved by using this part. We find the ratio of BD and BC. BD and BC. Similarly, let us use that the second information there given. What is that second information there? Come on. What is the second information? 4 MD is equal to AM. 4 MD is equal to AM. 4 MD is equal to AM. So, what is this? MD upon AM is equal to 1 upon 4. We are finding MD upon AM. This ratio we are finding. Let us find out MD and AD ratio. MD with AD. So for that, what is required there? MD and AM is there. So let us see that MD plus AM. What is the value there? MD plus AM. It will be AD, but it is not useful there. For that, first invertendo. What is invertendo? AM upon MD is equal to 4 upon 1. Now let us have that componendo. AM plus MD upon MD is equal to 4 plus 1 upon 1. And what is that? AM plus MD. AM plus MD is AD upon MD is there. So this is 5 upon 1. This is again componendo. Componendo. AD upon MD. AD upon MD. We require that MD upon AD. This ratio. What is the value there? 1 upon 5. So we can prove this. So what is the use of given information? We have to find out two ratios there. BD to BC. Find out. Then after that MD and AD. MD and AD ratio is 1 upon 5. This was required for the further proof. Now you take that triangle ABD and triangle ABC. Consider triangle ABD. Triangle ABD. ABD. Triangle ABD and triangle ABC. Area triangle ABC. If you observe them carefully, ABD base is BD, ABC base is BC, but common vertex is A. So definitely they are having the same height. So you can use that heights are equal. H1 and H2 are equal. In that case, you can see the ratio ABD upon ABC. Ratio must be equal to BD upon BC. But we know that what is the value of BD upon BC? It is 3 upon 5. We can substitute here. So this is 3 upon 5. We are finding BD upon BC. BD upon BC. It is nothing but 3 upon 5. So that is important relation. You are getting here very, very important relation between the areas of two triangles. Similarly, find out the ratio of areas of two triangles. BMD taking base MD. BAD taking base AD. AD base, MD base. You are getting B common vertex. So definitely on this line, AD, MD are in the same line and B is common vertex. So definitely they are having again same height, equal height. So we can find out the ratio of areas of two triangles. What is the triangle? area of triangle BMD divided by area of triangle ABD. Area of triangle ABD. Again, you can see that heights are equal. So, what is the base of BMD? We are taking MD. And what is the base of triangle ABD? We take AD. So, definitely MD upon AD. We can use that MD upon AD. And it is here MD upon AD. And MD upon AD, it is nothing but 1 upon 5. So, this is your second result. So, we are finding that values of ratios BD to BC, we have to calculate. After that, we use the ratio MD to AD, and they are having the same height. So, by using the property of areas of triangles having the same height, we are finding two important results there. What are the results? You can observe them: ratio of areas. And if you see that ABD is here and ABD is here, but after that, very interesting step. If you multiply both relations there, take the product. What is the first left hand side? Area of triangle ABD upon area of triangle ABC into this relation, area of triangle BMD upon area of triangle ABD is equal to is equal to 3 upon 5 into 1 upon 5. That is equal to, what is the value there? 3 upon 25. But you can see that ABD and ABD cancellation is there. So what is the final result you are finding there? What is the left hand side? It is numerator area of triangle BMD upon area of triangle ABC. And what was the question there? Area of triangle BMD upon area of triangle ABC, we are getting equal to 3 upon 25. So very interesting problem by using the ratio of areas of two triangles. By using the ratio of areas of two triangles, what is very important? BD and BC. BD and BC are on the same line, and A is the common vertex. In that case, this is the height of two triangles. So this is your first relation you are getting. Before that, we have to calculate BD to BC. We have to calculate BD to BC. After that, what is the pair of triangles? We are taking BMD and BAD, two triangles. But AM and AM, MD are on the same line, and B is the common vertex. In that case, definitely you can see there is common height of two triangles. What is the name of the triangle? ABD, and other triangle BMD. So we are finding that heights are equal. We can calculate the ratio of areas of two triangles. So very interesting problem we are getting, and try to use the property. What is the property there? Ratio of areas of two triangles. Observe carefully two triangles. Whenever you are getting two triangles, see that whether the bases are equal or whether the heights are equal, and use the property, the ratio of areas of two triangles. So I think all of you getting this point. Thank you.